Hi there. So today I thought I'd go through some functions using both f and g. Now, this is a two-part question. The first one being A, find f to the minus 1 x when fx equals 3x minus 2. Okay, for our first step, we're going to write out this function here, but replacing the fx function with a y. So we're going to get y equals 3x minus 2. Now what we're going to do now is swap the y and the x around. So we get x equals 3y minus 2, and then essentially solve for the new y. So I'm going to do this by isolating the 3y by adding 2 to both sides. So I will get 3y equals x plus 2, and then divide both sides by 3 to get y equals x plus 2 over 3. And this is very simple. This is immediate 2 marks, but we need to put it back into the function. So we will have f to the power of minus 1 x equals x plus 2 over 3. That's our finished answer. Now our next question is a show that question, where we have to show that 15x squared minus 24x plus 8 equals 0, when given that fgx equals 2gfx. Now I know this looks quite complicated, but we've been given both fx, which is 3x minus 2, and gx, which is x squared plus 2. Now we're going to have to do both sides here. So we'll start with the f of gx. So we're going to use gx, this whole function, as a replacement for x. So essentially put this whole function into this x. So we'll be getting f of x squared plus 2. But since this is the new value of x, we have to put this whole thing into the 3x, this x part here. So we're going to get 3x squared plus 2 minus 2, just like it is here. So 3 times x squared is 3x squared, plus 2 times 3 is plus 6, and then minus 2. So we'll just get 3x squared plus 4. And now this side's kind of the opposite. We're trying to work out two lots of g of fx. So we're going to be using this whole equation as our new x. So we're going to be doing 2g, then 3x minus 2, and then replacing the x's in this g with this new value. So 2, then, since we've got an x squared here, we're going to do this x bracket squared, and then put another bigger bracket around here because this is also multiplied by 2. So now we can expand it to be, leave that outside first because I want to expand this part first. I'll make it into 2 brackets, but they're exactly the same because that's what squared means. So we will get 3x times 3x, which is 9x squared, then 3x times minus 2, which is minus 6x, then the exact same thing again with these two, minus 6x, then minus 2 times minus 2 is plus 4, because the negatives cancel each other out, and then this this minus 2 on the end here. All of that's in the brackets, and all of that is times by 2. So after all of this, we will get 18x squared minus 12x minus another 12x plus 8 minus 4. So this will then be simplified down to 18x squared minus 24x plus 12. Now the question gives us that these two functions are equal to each other. So that means that 3x squared plus 4 is equal to 18x squared minus 24x plus 12. So we can put them on both sides of their own equation. So I'll write it out properly here that 3x squared plus 4 equals 18x squared minus 24x plus 12. Now essentially we've just got to do a simple moving around, so we get all of the x values on one side and then 0 on the other. So we're going to start by moving the 3x onto this side because there's more on this side and it's just easier to do it that way. So I will take it away from both sides to get 4 equals 18x squared minus 3x squared minus 24x plus 12. And then the last value 4, 0 equals 18x squared minus 3x squared minus 24x plus 12 minus 4. Now it looks quite complicated at the moment, but it's really not. There's just a lot that hasn't been simplified down yet. So 0 equals 18x squared minus 3x squared. 18 minus 3 is 15, so 15x squared. Then minus 24x, there's no other, only x value, so minus 24x. Then plus 12 minus 4, so that's 8 plus 8. Now the question asked us to show that this statement is true. Now this is another 5 marks in the bag. So please don't get worried when it says to show that something is true. It just means that you can't work backwards from the information that you're given in the question. That's all, folks. Thanks for listening.